Today we're going to write and graph equations of circles. Why would you want to know this? Well, so you can determine zones of commuter system or, I don't know, epicenters of earthquakes. On the next slide, we're going to look at the standard form of the equation of a circle. Be sure that you pause the video and write down this equation. You'll notice that this equation looks a lot like your distance formula. If you imagine that we had the radical above the left-hand side of the equation, all we did was square both sides. So by squaring it, it gets rid of the radical, and instead of having d on the right-hand side, we just have r, which represents radius, since we're working with circles, so it's r squared. Note that HK is the center of our circle, and r is the radius. And I'll show you that below. There's our center, and this is assuming that our circle is centered about the origin in this particular diagram. And then we have our radius and then a point on the circle. And you can see that if we connect our point, we can make a right triangle. Now we connect it with the Pythagorean theorem. We could say x squared plus y squared equals r squared. If you're wondering where all of this went to, remember this particular circle is at the origin, 0, 0. So if I put a 0 where the h is and a 0 where the k is, we end up with our x squared plus y squared equals r squared. On the next slide, we'll start with an easy example. Okay, it says write the equation, and we're going to say the standard equation of the circle shown. Again, this circle is, the center is at the origin. So it says the radius is 3. So we have our equation. We fill in the values that we know. And in this particular problem, again, we don't have an h and a k except that they are zeros, so I didn't bother to put those in. And then we just simplify our radius to 9. Let's look at another one. Okay, write the standard equation of the circle with the given center and radius. Now that we have a center that's not at the origin 0, 0, I want to remind you that we're going to call this h, k, and we'll be using this formula, which is the same as what we used above, but we just had zeros, so we didn't put them in. So go ahead and see if you can fill in the values. Okay, so hopefully by now you've worked out the problem. If not, hurry up and pause and work it out, but this is what it should look like. So we put in, now we have a double negative, a minus sign from the formula, and a -2, so it's going to become a positive. And then we just multiplied our 7 times 7 is 49. All right, on the next slide, we're going to look at a problem where we are given the center and a point, and we are not given the radius, so you must find the radius. Okay, so notice first, when we had our x minus h quantity squared plus y minus k quantity squared, and we didn't have the radical above it, and we had our r squared. So this is what it looks like before we square both sides, correct? Okay, so all I did was simplify underneath the radical to find out that our radius is going to be equal to the square root of 20. So now we have our radius, and we have our center. And that's what we need to be able to write a standard equation of the circle. So see if you can do that. You have your center, and you have your radius. Be sure you pause the video if you didn't do that already. But for those of you who are ready to move on, we took our center of -1, 2, and then because we square both sides, we got rid of the radical and we got the answer of 20. All right, now this time we're going to graph a circle. Again, we have our center. We can see that right here. And we have our radius. Okay, so notice that our radius changed. Whoops, I meant to use my drawing tool. But notice that our radius changed from 36 to 6 because on the first couple slides it was always like 7 squared and then it became 49, correct? Now we have to find the square root, and that's where that 6 came from. So we plotted our center for -2, and it says the radius is 6, and we're counting by 2's. So 2, 4, 6, 2, 4, 6, 2, 4, 6, and then down. And then we can kind of connect those points to make a nice circle. All right, so pause the video, see if you can do these, and then I'll pop in the answers so you can double check to see that you're doing them correctly. Okay, so number 1, and our origin is our center, so that's why it's just x squared plus y squared, and then the distance, or the radius, is 4, 1, 2, 3, 4, but then squared is going to be 16. Number 2. This time we had to include our center of -2, 3, and square our 3.8. And lastly, to graph, remember you're going to plot the center, and then you have to do something special to the radius. Okay, so we plotted our center. We went -1 up 3. And then the square root of 4 is 2. So that's why we're 2 from the sides of the circle. All right, so this final slide is quiz practice. Pause the video, and then I'm just going to pop in the answers. And then if you have any questions, we'll go over them in class about this slide.